children sleep longer than adults, but some children sleep shorter than what they should sleep for their age. Okay, so if you correct for that, you can see that there is a twofold increase in the risk for obesity and diabetes if you don't sleep enough as a child or as a young person. And that really is a very, very prominent finding in the literature. You can easily understand how that may relate to the situation in which the child grows up, socioeconomic factors, cultural factors, they may all play a role, but nevertheless, sleep duration, short sleep, seems to be a very prominent factor driving obesity. And as many as you will have seen, you go to a primary school or you go to a secondary school, and you start seeing many young children and young people who are too heavy. And one of the factors driving this is actually short sleep duration. How that relates to gaming, watching television, social media, or what have you, is another question. So the question is basically, where does this come from? What do we think about sleep? What is a short sleeper and what is a long sleeper? Why do some animals sleep long and other animals sleep far less? What are the fundamental links between energy intake and sleep? Now, this is an interesting story, and we'll see how my slide wants to proceed. We feel that sleep is for the brain, but it's also for the body. There's very little doubt about this. How can we come up with evidence that sleep has something to do with energy intake? Guess what? If you are a carnivore and you can get a lot of calories by just catching one prey, let's see, you say you are a lion, actually you will have a lot of time to sleep. If you are a herbivore, let's say you are a cow, and the caloric density of your food is very low, you have to spend a lot of time being awake and eating this very low caloric food. So there is a link at the level of comparing different species between energy consumption and sleep duration. So that's one way in which, from a biological perspective, you can see that there are links between sleep duration, and metabolism. There's another kind of thing you can do, and this is a simple experiment, although maybe not so simple. You can ask people to sit in a metabolic chamber, and in a metabolic chamber, you can measure how much energy people actually expend. And you can do this for 24 hours. So here from 8 o'clock in the morning to 8 o'clock. And then you can do this in 2 times. On one occasion, they go to bed at night. And in the other occasion, they stay awake. And you can see that during the day, obviously, it doesn't make a difference whether you are awake or asleep at night. But at night, it does make a difference. So sleep actually does reduce our expenditure. So there is a link there between sleep and metabolism again. Of course, that doesn't really explain why we see these associations between insufficient sleep and obesity. So for that, we need to do experiments. So this is Professor Eve van Kouter. She originally was from Belgium, but spent most of her career in the University of Chicago. And she really pioneered studies to look at this link between sleep duration and aspects of food intake, hunger, satiety, and what have you. she did simple experiments. You know, she asked people to only sleep for 4 hours a day for 2 days, and she compared this to people being in bed for 10 hours for 2 days. And then the next day, she asked people, how hungry are you? Okay. And guess what? In red is how hungry you are if you didn't sleep enough. And what you can see is that throughout the day, people feel more hungry if you didn't get enough sleep. In other words, not getting enough sleep makes you hungry. Of course, it's also true that when you are hungry, you eat more. A sleepy brain is a hungry brain. Basically, what your brain is saying, oh, well, I'm sleepy. That must be because I didn't eat enough. I need more energy, so let me eat more. And this is a measure of global appetite. How much would you like to eat? And you see a similar pattern. So sleep loss makes you hungry. And when you're hungry, you eat more. The question, of course, is, can you measure this? Or can you come up with physiological correlates of that behavioral effect? And yes, you can. And this is, again, work from F. von Kauder. So what she did, you know, she measured throughout the day effects of sleep restriction on leptin and ghrelin. So leptin is produced by fat cells in the body. And if the leptin levels are high, you will stop eating, and certainly in the long term. And what you can see is that sleep restriction actually throughout the day lowers those leptin levels. Okay, so the physiological signal that would normally contribute to you stopping eating is lower. Okay, so we start understanding some of the mechanisms. There is another appetite modulator, ghrelin, which is produced by cells in the intestine and the stomach. And that actually makes you hungry. Yeah. And what you see is that if you don't sleep enough, these levels of ghrelin go up. So there you are. You think that, oh, I didn't sleep enough. That just makes me sleepy. But what it actually also does, it makes changes in those biological mechanisms that regulate your eagerness to eat. And that probably is a cause of those associations. So, you know, people have looked into this in more detail and said, what happens if you don't sleep enough to your glucose metabolism? And this is again work from the Chicago lab, in this particular case, Karine Spiegel. And if you don't sleep enough, you will actually have a 40% slower glucose clearance in response to a standard glucose tolerance test, yeah, where there is an infusion of glucose. And you will have also a 30% lower acute insulin response to glucose. So it's not just that these modulators of appetite and hunger are regulated, it's also that the downstream mechanisms that help you to take care of the food you eat are affected. Now, of course, 4 versus 12 hours is not very relevant. We did some experiments in Surrey. This is with Denise Robertson, professor at Surrey. And what we did here is, the previous studies were all laboratory studies. We did a study in the field where we asked people to actually sleep their normal sleep duration, or at home for 3 weeks, reduce their sleep duration by 1.5 hours. And then we did quite a few measurements. We looked at sleep duration. Of course, there was less sleep and sleep restriction. We looked at insulin sensitivity. Initially, we did find changes. We looked at leptin. We did find changes in leptin, dynamic changes, and we looked at body weight. So even though the responses are complex in terms of their dynamics, we did find effects of that sleep restriction on those variables. Now, of course, what you really would like to do is find out what happens if you are somebody who doesn't get enough sleep, but now you're going to sleep more. Yeah. Can you now see positive effects of sleep extension? Well, we have done this in a pilot study, which we never published, but I'll come back to that. So we took people who are habitual short sleepers. Yeah. So they normally slept less than 6 hours. And then we told them to sleep 1.5 hours longer. Okay. And do this for 3 weeks. And of course, yes, we were successful in increasing their sleep duration. People did manage in their busy schedules to find more time for sleep. And then we also looked at body weight. And actually, we did find that when you extend sleep, there is a reduction, or at least compared to the normal situation, a reduction of body weight, which if you want to get lean, you have to sleep more. This was a pilot study. You know, what happened a year ago, Ezra Tassali, he's in Chicago, did a large study published in JAMA, which is a reputable journal, Internal Medicine, effects of sleep extension on objectively assessed energy intake among adults with overweight in real-life settings, a randomized clinical trial. So she had 41 people randomized to the control group, no change, and 40 people randomized to the sleep extension group, okay? And then she measured many things. So this is the sleep duration data. It stays the same over the 4-week period in the control group, but there is an increase in sleep in those people who were told to sleep longer. And if you do look at some of the data, you see that if you look at the change in energy intake measured in kilocalories, there is a correlation with the change in sleep duration. If you manage to increase your sleep, you will actually consume fewer calories. On average, there was a difference of 270 kilocalories per day, you know, which is not too bad. If you assume that normally you use 2,000, maybe 2,200 or 2,300, that's more than 10% difference in energy intake. And they also found a weight change in terms of a difference between the extension and the control group of approximately 1 kilogram, which may not seem a lot, but that's only a 2-week extension. If you do this for a year, that would be 24 kilograms if we can extrapolate things in that particular way. And maybe this is where I want to stop and start asking whether there are any questions. Thank you very much.
Thank you, Professor. That was a very informative presentation.